Hey guys, welcome. This is 13.1, Lorenz curve and the Gini index. Okay, so what we're going to be doing today is finding the area between two curves. All right, which means we're going to have to graph the given functions. We're going to have to find which function is f of x, which function is g of x. And then we're going to have to see where f and g are to set up an appropriate integral. And once we set all that up, we can calculate. So, sounds great, right? With that being said, here's the definition of an area between curves, right? I guess not even Lorenz curve. We'll just call it area between curves. Okay. So if f and g are continuous, and if f of x is greater than or equal to g of x on the interval AB, then the area bounded by f of x and g of x for a given interval AB is exactly given by the area A between f and g is equal to the area under f minus the area under g, or the integral from A to B of f of x minus g of x. All right, that's what we're going to work with. Okay, now to set up our problems, there's going to be three cases we have to look at. And it's all going to be based on the problem we're given. Case one, if function f is greater than function g, and it's continuous and positive over this interval AB, then the area bounded by the graph of f and g for the interval AB is given by the integral from A to B of f of x minus g of x. To put it simply, in order to use that formula above, f of x must be above g of x. So the graph of f must be above the graph of g. If so, we get to use this formula. That's it. Simply put, this is why we're going to graph things today, to see how it works. Okay, case two says if f of x is less than g of x, meaning that if the graph of g of x is above f of x, then we will use this formula, the integral from A to B of g of x minus f of x. And this works if g of x is above f of x, as you see by the graph below. Okay, that's case two. Case three, now on some interval AC, if f is greater than g from the interval AB, and g is greater than f on the interval BC, then two integrals are needed. So the area is going to be given by the area 1 plus area 2. So you see that on this graph, from the interval A to B, we have one area. So that would be area 1, which is the first integral setup, which means f of x is greater than g of x. And then from the interval B to C, we have another area, which would be area 2, which gives us the setup for the second integral. So this may happen, all right? And if it does, well, we know we're going to have two integrals. Okay, so these are the three cases for finding the area between two curves. So now, given the problem, let's see what case we need. We need. All right. So, example 1, find the area bounded by f of x equals 6x minus x squared and y equals 0 for the interval 1 to 4, right? For the interval 1 to 4. So this interval is the same as 1, 4, okay? All right. So first thing we want to do is graph the two functions. Graph the two functions. Okay, so we're going to start with f of x. All right, so here's step A. What room do I have to work with? Let's see. Lots of room here. Okay. All right, small, of course, like I always do. Okay, so step A. we're starting with f of x equals, what was it? 6x minus x squared. 6x minus x squared. Okay. And then I'm going to make an XY chart for it, so we know how to graph it. And they are already giving us the numbers to choose. They say, choose the numbers from 1 to 4. Choose the numbers from 1 to 4. So that's where my x values will be. They're going to be 1, 2, 3, 4. Now take all these numbers and plug them into the function above. Six x minus x squared. 1 is going to give me 5. 2 gives me 8. 3 gives me 9. 4 gives me 8. Okay, so there's f of x. Now we want g of x. And g of x is going to be this one, the y equals 0. So this is going to be my g of x. So I'll make an xy chart for that. So this means that g of x equals 0, right? It's the same as y equals 0. Same exact thing. Now, make an xy chart and choose the same numbers. 1, 2, 3, 4. And no matter what x value I choose, y is always going to be 0, 0, 0, 0. Okay, well, now let's plot my two x, y charts. Okay, so we're going from 1 to 4 on the x values. So that means on my graph, I can actually, let's see, I can skip my intervals. So I can say this will be 0, 1, 2, 3, 4. And then the y values I have are 5, 8, 9, 8. So my y values here can stay exactly the same, 5, 8, 9, 8. So if I were to label this, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Okay, let's plot the first function, which is here. 1, 5, 2, 8, 3, 9, 4, 8. So 1, 5. Here, maybe I could just zoom out a bit. Sorry. 1, 5. So 1, 5, 2, 8. Oh, that's not 1. There's 1. 1, 5, 2, 8, 3, 9, 4, 8. There we go. This is f of x. Okay. And then let's graph g of x. 1, 2, 3, 4, they're all at 0. So 1, 0, 2, 0, 3, 0, 4, 0. So it's just this line right here. And this is g of x. Okay, so we have sketched our graphs, and now what I'm going to show you is the area that we are looking for. So oh, I didn't extend that over there, did I? Nope. This should have been 4, 8, right there. There we go. Okay, and then okay, so what we are looking for is the area that is between these two curves. So we're looking for all of this area in here. So that's what we're doing. So with that being said, we now have sketched both graphs, and now we want to know what case applies to this. So what case is going to apply to this? Now you see on our graph that f of x is above g of x. So not case 3, not case 2, case 1. Case 1 has f of x above g of x, which means we get to use this integral of f of x minus g of x, okay? So this will be a case 1. So that's all B wants. B says, what case is it? And B says, this is a case 1, meaning we'll use the integral from a to b of f of x minus g of x dx. That's what case 1 says. Okay, which means we can move on to step C to find the area. All right. Step C. We're going to have the integral from 1 to 4 of what is f of x? F of x is 6x minus x squared. Right? F of x minus g of x. Well, what's g of x? G of x is 0. 6x minus x squared minus 0 dx. Okay. Well, what happens is that this becomes just the integral from 1 to 4 of 6x minus x squared dx. 6x minus x squared dx, which means we can now move on to find the antiderivative. Okay, with that being said, this becomes 6 times x squared over 2 minus x cubed over 3 evaluated from 1 to 4. Still got room to play with. Perfect. Which means that clean this up, and this becomes 3x squared minus 1/3 x cubed from 1. Oops. From 1 to 4. Type that in my calculator. Let's see. 3x squared minus 1/3 x cubed from 1, so type in 4. 4, I get 80/3 minus 1, I get 8/3. Which would give me 72/3, which is 24. 24. And for my math lab, it says that your area is 24 square units. I mean, because it's area, right? Okay. And there you go. That's how we work these. So we graph, we find the case, and then we do the work, right? We apply the appropriate case. Okay. So what you are actually looking at is the sum of the infinite amount of rectangles inside this area. So if I were to erase these squigglies and make rectangles inside here, well, I would have a rectangle here. I would have a rectangle here, here, there, there, and there. And believe it or not, if you added up the area of all these rectangles together, this would give you 24, or something close to 24. Because let me see this first rectangle. Let's see. This would be probably an area of 5. This one looks like it'd be an area of, let's see, 6. This one would be 8. What's that? 5, 11, 19. Actually, I think they actually be half that, because those are halves. So this would be 5 halves, 6 halves, 8 halves. This one would be 9 halves. This one would be 8 halves, and this one would be 7 halves. So if you added all these up, you would get a number close enough to 24. So all I'm saying is that inside this area, there is an infinite amount of rectangles that we are finding the sum of. And it just so happens that the integral does it like that, much faster. Okay, so don't worry about any of this, okay? I just thought it would be cool to show you what's actually going on, what this formula is actually doing. Back to the squigglies. There you go. Okay, so that's just what's going on behind the scenes. All right, let's do it again. 2. Find the area bounded by y equals 2x plus 6 and y equals 3. All right, so with that being said, y equals 2x plus 6 will be f of x. Y equals 3 will be g of x. And remember, this interval is the same as -1 to 2. Okay, well, let's make some XY charts because we want to graph it. So for A, we have f of x equals 2x plus 6. And for my XY chart, we have -1, 0, 1, 2. Okay, plug those in. Let me see, 2x plus 6, -1 gives me 4, 0 gives me 6, 1 gives me 8, 2 gives me 10. Okay, and then g of x. G of x is 3, which is the same as y equals 3. And from the xy chart for this one, you get -1, 0, 1, 2. And no matter what x value you plug in, this will always stay 3, which means we are now ready to graph. So my x values are -1 to 2, so I can make my xy chart appropriate. Let me zoom in as much as I can. There we go. So this will be -1. Oops. -1, 0, 1, 2. -1, 0, 1, 2. And I think the highest it said I went to was 10. So if I made these appropriate, well, I'll just go by 2s. So right here, 2, 4, 6, 8, 10. Beautiful. Okay, and now let's graph using our XY charts. And first one, I'm at -1, 4. So right there. 0, 6. Right there. 1, 8. Right there. And then 2, 10. Right there. So here is f of x. There's f of x. And then let's do g of x. So g of x is -1 and 3. So right here, somewhere around there. No, stop it. -1, 3, 0, 3, 1, 3, 2, 3. And there's g of x. Okay. Once again, zoom in. We want to find the area between these two graphs. And once again, here it is. F of x is above g of x, which means we will use case 1 again. So with that, I'm going to say B. This will be case 1, which means, again, we're going to use the integral from a to b of f of x minus g of x dx. Okay, which now brings us to step C. Let's do it. So C, we're going to have the integral from -1 to 2 of, and what do I have? F of x is 2x plus 6. 2x plus 6 minus g of x, which is 3. 3 dx. Okay? Clean it up, and this becomes the integral from -1 to 2 of 2x plus 3 dx. All I did was add this 6 with that -3. 2x plus 6 dx. We are now ready for the antiderivative, which means that this will become 2 times x squared over 2 plus 3x, evaluated from -1 to 2. Then you get x squared plus 3x evaluated from -1 to 2. Okay, let me type that in the calculator. Let's see what we get. X squared plus 3x. Type in 2, I get 10 minus, if I type in -1, I get -2. So our answer is 12. 12 square units. All right, perfect. Good to go. So, same exact thing again. Graph them, figure out the case, set up the integral. Okay. More. Okay, find the area between the graph of f of x equals x squared minus 2x and the x-axis. So the x-axis is also known as the line y equals 0. So this means that y equals 0 is going to be our g of x. And we want this over the interval -1 to 2. Hey, that's like the last interval. Okay, so first thing, make your XY charts. So, A. F of x equals x squared minus 2x. Make my XY chart. And they're giving us the numbers to plug in again. The interval is -1 to 2. So those are the numbers we're going to choose. -1, 0, 1, 2. Type it in. X squared minus 2x. -1 gives me 3. 0 gives me 0. 1 gives me -1. And 2 gives me 0. Okay. Do g of x. G of x equals 0. Don't go slow on me. Come on. Make our XY chart. And -1, 0, 1, 2. And again, no matter what x value I pick, y is always going to be 0, 0, 0, 0. Okay, perfect. Now let's go to the graph, label it appropriate. Our intervals from -1 to 2. So that's how I will label the x-axis. So here's -1, 0, 1, 2. All right, and then my y values, I go to 3 and -1. So I can probably just space this out. So watch this. Since I go to 3, this will be 1, 2, 3. And then this will be -1. Okay, let's graph. All right, first one is up. All right, -1 and 3, we're graphing f of x. -1, 3. There we go. 0, 0. 1, -1. And 2, 0. So here is f of x. So this is f of x. Okay, let's graph g of x. -1, 0, 0, 0, 1, 0, 2, 0. This means that we are just like that. And there's g of x. Okay, let's zoom in. Let's see what's going on with the area. Okay, so we're going to want the area in between here. And we're also going to want the area down here. So if you look at this graph, I'll write it down somewhere. On the left side, we read the graphs left to right. So on the left side, you see that on -1 to 0, f of x is above g of x, right? For this one. And then we see that on 0 to 2, g of x is greater than f of x. Right there. So this means that we have an interval where f is greater than g and g is greater than f. So let's look back at the very first page. And this means that it's going to be a case 3. Because now we're given some interval a to c where f of x is greater than g of x and g of x is greater than f of x. This means we are going to need 2 integrals. So this means we are using this whole formula here. Okay, that's what we're using. All right. So case 3, let's go back. So this will be B. This is a case 3. B is a case 3. Okay. Yes, 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 which means that we are going to use the integral from a to b of f of x minus g of x plus the integral from b to c of g of x minus f of x dx. And there should be a dx right there. Okay, so that's our setup. All right. So since we're reading it from left to right, the first interval AB is going to be -1 to 0. -1 to 0. So we are going to start step C. All right. C. The integral from -1 to 0 of f of x, which is x squared minus 2x, of x squared minus 2x minus g of x, where g of x is 0. This will give me 0 dx plus, now we introduce the second integral. The integral from 0 to 2, that's the second interval we're given, as shown above on the graph, 0 to 2. And this is g of x minus f of x. So this will be 0 minus x squared minus 2x dx. Okay, cleanup time. Here we get the integral from -1 to 0 of just x squared minus 2x dx plus the integral of 0 to 2. And what we're going to do here is take this negative and distribute it to both terms here and here. So what this is going to become is negative x squared plus 2x dx. Yeehaw, right? Okay, we are now ready. We'll start with the first integral, which means that x squared becomes x cubed over 3 minus, oops, x cubed over 3 minus 2 times x squared over 2. And this is being evaluated from -1 to 0. Plus the second integral. I'll do it in another color. Come on. There we go. Of negative x cubed over 3 plus 2 times x squared over 2. And we are evaluating this from 0 to 2. Okay, more cleanup. Rewriting this, I get 1/3 x cubed minus x squared from -1 to 0 plus -1/3 x cubed plus x squared from 0 to 2. All right. There you go. Now, let's type in our numbers. All right. Let me see what I got. 1/3 x cubed minus x squared. If I type in 0, I get 0. So this gives me 0 minus, if I type in -1, I get -4/3. Plus, all right, this is -1/3 x cubed plus x squared. If I type in 2, I get 4/3 minus, and if I type in 0, I get 0. All right. Well, clean up some more. Minus, minus, we know makes plus, right? So this becomes 4/3 plus 4/3, which gives me 8/3. There it is. That's 8/3 square units. Or 2.6666666667 square units. So this could also be 2.67, whatever it wants. Okay, awesome. There it is. That's how you work case 3. All right, still going. Let's do it, let's do it. Not bad. 4, find the area bounded by x squared minus x and g of x equals 2x for -2 to 3. Hey, it gave us f, it gave us g. That is nice. The only thing you should know, again, is that this is the same as -2 to 3. So, let's do our xy charts. This is A. So for f of x equals x squared minus x. My xy charts, they're giving us the numbers to pick, -2 to 3. So -2, -1, 0, 1, 2, 3. Let's plug those in. X squared minus x, -2 gives me 6. -1 gives me 2. 0 gives me 0. 1 gives me 0. 2 gives me 2. And 3 gives me 6. There's that. Then we have g of x equal to 2x. Ugly. XY chart. -2, -1, 0, 1, 2, 3. And that should give me -4, -2, 0, 2, 4, 6. Okay, so I'm using -2 to 3. So let me make my x-axis appropriate. 0, -1, -2, 1, 2, 3. And I think I saw the largest y value was 6. The smallest was -4. So again, I can say 2, 4, 6, and -2, -4. Which means we are ready to graph. So first up is f of x, -2, 6. So -2, 6, -1, 2, 0, 0, 1, 0, 1, 0, 2, 2, and 3, 6. There we go. So here's what my f of x will look like. Something like that. Maybe a little better, but oh well. Let me try again. There's f of x. And then g of x. -2, -4, which is down here. -1, -2. And then 0, 0, 1, 2, 2, 4, 3, 6. So there we go. Looks like we're going to have another case 3 on our hands. Because we want this area and we want this area. So again, well, first, this is g of x. Okay, and what we notice is that on the interval -2 to 0, f of x is above g of x. F of x is greater than g of x. That's all of this right here, right? The blue line is above the pink line. Okay. So that's what's going on for that area. And then on 0 to 3, g of x is greater than f of x. And that's what's going on right there. Okay, so this is definitely another case 3. So this is B, case 3. So again, 2 integrals. Integral from A to B, f of x minus g of x dx, plus integral B to C, g of x minus f of x dx. Okay, let's set it up, which means we move on to step C. And for C, we'll have the integral from, what's the first one? -2 to 0. from -2 to 0 of f of x, which is x squared minus x, minus g of x, which is 2x. Dx plus the integral, oops, too much. The integral from 0 to 3, because that's our next one. Or is it 0 to 3? Of g of x, which is 2x minus f of x dx. All right, 2x minus f of x. Yeah, we're good. Okay, clean up. This will give me the integral from -2 to 0 of x squared minus 3x dx, because that negative x minus the 2x, negative 3x, plus the integral from 0 to 3 of negative x squared plus 3x dx. This negative distributes, makes a negative x squared, makes that positive x, and 2x plus x, 3x. There we go. Let's now find the antiderivatives. And you'll get x cubed over 3 minus 3 times x squared over 2 evaluated from -2 to 0 plus negative x cubed over 3 plus 3 times x squared over 2 evaluated from 0 to 3. Clean up again. Make it look pretty. 1/3 x cubed minus 3/2 x squared from -2 to 0 plus -1/3 x cubed plus 3/2 x squared evaluated from 0 to 3. All right, let's see what we got. 1/3 x cubed minus 3/2 x squared. Type in 0, I get 0. 0 minus, type in -2, I get -26 over 3. Plus, now that is -1/3 plus 3/2 x squared. Type in 3, I get 9/2. Let me see. -1/3 x cubed plus 3/2 x squared. I type in 3, I get 9/2 minus, and type in 0, we get 0. Okay. Put it together. And this becomes 26/3 plus 9/2 gives me 79/6. Or 13.17 square units. Yeehaw. Okay, awesome. Let's see if I can do it later. Okay. All right. Another one. I know, these are fun, right? All right. 5. Find the area bounded by y equals e to the 0.5x and y equals -1/x for the interval 1 to 2. Oof, this one looks good. All right, so this one will be f of x. This will be g of x. And again, this is 1 to 2. Okay, let's make our xy charts. So f of x equals e to the 0.5x. And we want it on the interval 1 to 2. So for my xy chart, you got 1. I'll choose a number in the middle, 1.5, and 2. Okay. E to the 0.5x. If I type in 1, I get 1.65. If I type in 1.5, 2.12. And if I type in 2, I get 2.72. Okay, there's that. And then for g of x, well, if you want to know how I type that in, which you probably do, let me see. I'm going to say share. That'll stop that. I'm going to share this. I did clear table second natural log e to the 0.5x. Enter, 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 enter. And I did 1, 1.5, and 2. That's it. That's all I did. Okay. Let me stop that share. I'll come back here. Let me see. Zoom in, share, share, share. Bam. Boom. Okay. Perfect. And then g of x is what? -1/x. So -1/x. And my xy chart, x and y, same numbers, 1, 1.5, and 2. Let's see, -1/x. Well, I get 1, which gives me -1. 1.5 gives me -2/3, or 0.67. And 2 gives me negative 1/2. Okay, perfect. Let's graph. We're only using 1 to 2. That should make things easy over here. So here's 0, here's 1, here's 2. My y values, I have -1 as the lowest, and 2.72 is the highest. So we'll go up to 3. And I can skip around again. So 1, 2, 3. And then down here, -1. All right. All right, let's graph it again. So blue, increase, we're good. All right. So graph the first one, 1 and 1.65. So probably put that around here. And then 1.5 and 212, probably like right there. And then 2 and 2.72, probably like right there. And here's what f of x looks like. It's a nice little curve. There it is. There's f of x. Okay. And then g of x is 1 and -1. So down here, 1, -1, 1.5 and -0.67. So probably right here, I'd put it. And then 2.5. So right there. So again, -1 over x is also a nice little curve that looks like this. This is g of x. Okay. So piece it together. We want the area between these two graphs. And you see how f of x is above g of x? Well, this will be a case 1. All right, so this will be a case 1. All right, so this means that B will have a case 1, which means we'll have the integral from a to b of f of x minus g of x dx. F of x minus g of x dx. Okay, well, let's set it up. And we'll start with C. We're going to have the integral from 1 to 2 of f of x, which is e to the 0.5x. So e to the 0.5x minus minus g of x, which is -1 over x. dx. Okay. Clean up. This becomes the integral from 1 to 2 of e to the 0.5x plus 1 over x dx. Okay, we're now ready for the antiderivative. All right, so this first term uses that new rule we learned, which means the antiderivative of e to the 0.5x is going to be 1 over 0.5 times e to the 0.5x plus the antiderivative of 1 over x uses a rule we know already as a natural log. So this will become the natural log of the absolute value of x, and we are evaluating all of this from 1 to 2. Evaluate from 1 to 2. Okay. Oh, ran out of room. All right, which means, we're ready to calculate. There's no need to make this look pretty because we can't. So let me type this in the calculator. Actually, right there, right? So table, let's see, fraction 1 over 0.5 e to the 0.5x plus the natural log of x. If I type in 2, I get 6.12 minus, if I type in 1, I get 3.30. 6.12 minus 3.30, we get 2.82. There we go. All right, those applications are done. Oof. Okay. Now we get into the actual word problems. Okay. Which means we still have a lot to go. What time is it? 2:37. Because I won't be able to finish this video in time, so I'll stop it here. We'll make this part 1, and then when I have more time later, I'll make part 2. So this will work. Okay, so this is where we'll stop for now.